Now onto plugs, or more specifically, 3-pin plugs. So in the UK, we have 3 pins on our plug, and we need to know what each one of them does. If you've travelled abroad, quite often you might see 2 pins, but we need to talk about 3 pins. We need to talk about the different colours and link them to the different names and uses. So let's start with the brown one. That's the live wire, and that's connected to the fuse. The blue one is the neutral wire. And the last one is the earth wire, the green and yellow striped. So for the exam, you need to be able to identify not just the colours, but also what they do. It's useful to compare a 3-pin plug to that of a normal circuit. We know from a normal circuit the cell pushes the current in one particular direction, but we need to close the loop by connecting it to the negative terminal of the cell. A plug is no different. So the live wire, that's this one just here, the brown one, carries the alternating potential difference from the supply. So in other words, that's the same bit of the battery just here. But then we still need to complete the circuit. And the name given to that part of the wire is the neutral wire, and it's the neutral wire that carries the current back round to the negative terminal of our cell, if that's what we're comparing it to. In terms of the national grid, however, we've got the live wire, that's the feed in to the appliance, and the neutral wire completes the circuit back to the national grid. The third wire is called the earth wire, and that's a safety wire. That stops the appliance from becoming live. Not all appliances have an earth wire, so if they're wrapped in plastic, they won't need to have an earth wire, because if the live wire comes loose and touches the plastic, that shouldn't be an issue. But if you've got a metal outer casing, so maybe a metal kettle, you will have an earth wire, so if the live wire becomes loose and touches the metal kettle, the excess electricity will flow from the surface of the kettle, the casing, through the earth wire, back literally to the earth, rather than electrocuting you via your hand. So the potential difference between the live wire and the earth is about 230 volts. We've got 230 volts in, as we saw on the mains electricity video, AC and DC a moment ago, and then the earth wire is attached to the earth, so we say that's got 0 volts. So the difference is 230. To complete the circuit, the neutral wire is there, and that is close to or about 0 volts. And finally, the earth wire is also at 0 volts. There'll only be a potential difference if there is a fault, and that will then allow the current to go through the earth wire rather than through you and electrocute you, like I mentioned a moment ago.